Hi everyone, welcome back. I hope everyone is enjoying their time and doing this. I've heard a lot of good things when I've been doing my Zoom meetings in the afternoon. So hoping that will continue and you guys will still be good to go with this. So I want to go over a couple problems today. First one is going to be this one right here. So on Monday, Sylvania spends 5/12 of a day driving to her cousin's house. On Friday, she spends the same amount of time driving home. What fraction of a day does Sylvania spend driving to her cousin's house and back? Now, this is the most important part. So, I'm not much of an artist, especially when it comes to drawing on the computer, as some of you might have seen. But if you're at point A and you spent 5/12 of the day traveling to point B, A and B, and you spend the same coming back, so 5/12 going there and 5/12 going back, we can represent that as an addition problem as 5/12 plus 5/12. Now, how could we represent that as a multiplication problem? We could represent that as a multiplication problem using 5/12 times 2. So I'm going to pause here for a second. I'm going to go to my other screen. So like I said, 5/12 times 2 is what our actual multiplication problem was. Now, we know that when we're dealing with this fancy thing right here, we can represent this. I already have my denominator of 12, and we can represent it as 1, 2, 3, 4, 5. But we're multiplying this by 2, so we're actually going to have to put another 5/12 in here. And that one is also going to be 5. Now, if we did this total, what would our total amount be in these two fraction bars right here? These ones right here. What is our total that is shaded? Our total that is shaded is 10. So our final answer here is going to be a total of 10/12. Now, some of you may have figured out the mathematical way to do this, and I'm going to show you that as well. A whole number can be represented as a fraction. And the numerator is actually going to be the 2, and the denominator is going to be over 1. Now, we actually did this earlier in the year. I don't know if you guys remember or not. But when we're doing that, multiplying fractions is unlike adding and subtracting fractions. When we're multiplying fractions, you can just multiply across the top and multiply across the bottom. So multiplying our numerators would be 5 times 2, which is 10. And multiplying the denominators would be 12 times 1, which is 12. So, as you can see, this number and this number are the same numbers, which is pretty cool. So those are two different ways that you can show this problem. Okay, so now we're going to work on one more problem before I let you go, and this one's going to be a little bit different. So, I should go up a little bit. So, Micah jogs 8/10 of a mile. Sarah jogs the same distance 3 days in a row. How far does Sarah jog altogether? Now, I told this to Miss Murray. I have Miss Murray look at my problems before I make my video, and she said there's no way that she would jog that amount of time. She's not much of a runner. So, if Micah jogs 8/10 of a mile, and Sarah jogs the same distance 3 days in a row, we can even draw a little picture here. So this would be 8 over 10, 8 over 10. Maybe I shouldn't have drawn a picture because I can't draw very well, and 8 over 10. So when we're doing that, we can actually multiply that by how many? What would our problem look like here? Our problem would look like 8/10 times 3. And I'm going to show you that in this one. So we already have figured out that when we're multiplying fractions, we can put our whole number over 1 and multiply our numerators and multiply our denominators. So 8 times 3 is what? It's 24. 10 times 1 is what? That's 10. Now we have a little bit of a problem here. 24 over 10 is what we call an improper fraction. So I had this over here, and I'm actually going to show you what 24 tenths looks like, and we're going to try to figure out what we can do. So I'm going to count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Now, we need to get all the way up to 24, so we need another one of these. Boom. I'm going to do another one of 10. So I'm already at 10. And remember, our numerator is how many filled in spots that we have. So let's do another one. So we already have 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. We still need another couple more, so we're going to do one more. Now we're at 20 now. 21, 22, 23, 24. And if you notice, these two are filled completely in. So we can actually say that's a whole number. Darn it. There we go. We can actually say that these are whole numbers. So this equals 1, and this equals 1. And 1 plus 1 equals what? Yeah, you guys know that one. 1 plus 1 equals 2. So if this is 2, if this equals 2, then we have a remainder, which is down here. So this would be 2 and 4 tenths. Nice job. Well, to be honest with you guys, I'm really proud of each and every one of you working so hard on this. I know this is not easy, and I know that it's difficult for you guys to do, and I really appreciate you guys putting in your best effort. If there's anything I can do to help you or help your family with this whole math thing, please let me know. Send me an email. Well, it's been good talking to you guys, and I hope to talk to you soon. See ya.